Okay. Microphone on.
All righty, welcome for the second hour of Colonel Bledsoe's visit with us here at Arizona 2006-3. This hour he will be talking to him about SR71 experience. I looked at the brief. There's actually a lot of history there. It's a pretty neat American history that at one time was very secret, to be perfectly honest, and now it's not so secret. And we have the actually very accomplished pilot. He has the closed course speed record over 2,000 miles an hour. Everybody give him a round of applause, please.
Hey, thank you, Colonel Peoples. Well, today I'm going to tell you about the SR71. We'll start with a little history about why and how the airplane was built, and then we'll go into some details about the airplane itself, tell you about the missions we flew, and then just to summarize the records still held by the airplane and so forth. All right, why was the airplane built? It was built back during the Cold War between the U.S. and the Soviet Union. The U.S. felt that we needed to know what kind of capabilities the Soviets had, particularly in their bomber forces and their ICBM forces.
I can agree. Just again, remind everyone here, this is prior to satellites, okay? If we had to go spy on a country, you couldn't click up Google Earth and look at it, okay? You had to actually fly. Brave men had to fly over these countries and be shot at just to get a picture, literally. I mean, it's beyond our comprehension now. Brant? Yes, sir.
Okay, the U-2 became operational in 1956 and started flying missions over the Soviet Union. That lasted until May of 1960 when Francis Gary Powers was shot down and captured by the Russians. And that was the last U-2 mission over the Soviet Union. Before then, the CIA and the Air Force had already started development of a follow-on to the U-2. They decided they needed something a whole lot faster because the U-2 only flies at about 420 knots, although it goes up to 70,000 feet or so.
U-2 only has like one landing gear, right?
Well, it's got what they call a bicycle gear. It's got one main landing gear on the fuselage and another tail wheel behind it.
Yeah. So when it's slowed down and tip over on one side, you have like a skid on the wing.
Yeah. But anyway, the U-2 would fly very high, the highest flying airplane of its era, but it was slow. So it became vulnerable to Soviet surface-to-air missiles. Go back to that one, please. Okay, so the Air Force and CIA asked for proposals from mainly Lockheed and Convair to build a successor to the U-2. They wanted something that was fast and high and, if possible, stealthy, although stealth wasn't a real common term at that point. So Lockheed's A-12 design won the competition. The A-12 is an airplane that looks almost identical to the SR-71. It became operational in the mid-60s. The main difference between the A-12 and the SR-71 is the A-12 only has one seat and it had one big camera. The SR-71 has a pilot and a radar systems officer, reconnaissance systems officer. It had several different types of cameras, plus radar, plus electronic intelligence capability, and it carried about 12,000 pounds more fuel than the A-12, so it had longer range. Okay, this was the requirements laid down by the CIA and the Air Force. They wanted a cruise speed of Mach 3 or faster, cruise altitude of 80,000 feet or higher. They wanted a low radar signature, in other words, stealth, range of 3,000 miles or better, extended with refueling, a precise navigation system with no emissions. That meant they couldn't use Doppler radar for navigation, which was commonly used by bombers and at the time. And they want varied types of sensors, cameras, radar, electronic intelligence. This was some of the proposals considered before they decided on the A12. This was Convair's proposal, which was actually planned to go faster and higher than the A12 or the SR71. The problem was it had to be launched at Mach 2.2 to make it work. So they had a scheme to carry it below a B-58 bomber.
Like the X-15.
Yeah, similar. But it had to get up to Mach 2.2 to make the ramjet engines work. So it took a whole lot of support and it was impractical. CIA asked Lockheed to come up with a competing proposal, and they came up with one that was similar design. But both of them were ruled out because of poor reliability of ramjets, no go-around capability for a landing. And once it was mated with the B-58, there was no way for the pilot to escape in an emergency. So, why did we need a speed of Mach 3? Well, the primary Soviet air defense missile for high altitude at that time was the SA-2. And if you look at this chart of SA-2 capability versus SR-71 or A-12 speed, and you analyze it, you'll find that the only way they had a realistic chance of shooting down an A-12 or an SR-71 was to launch the missile before we came into radar range. So it wasn't really a threat. Here's the man who designed both the U-2 and the SR-71, Kelly Johnson of the Lockheed Skunk Works, one of the real aeronautical geniuses of the 20th century. He also designed the P-38, the F-80, and the F-104. Okay, some of the problems that had to be overcome during the development of the airplane were primarily related to heat. The faster you go, the hotter the surface gets. This is due to compressibility of the air. If you look at the formula, you'll see that the temperature is related to the square of the velocity. So it's not really a problem for most airplanes till you get above about Mach 2.5, and then it just goes up astronomically. That is the reason that most fighters, even today, are limited to a top speed of about Mach 2.5, even the F-22, F-15, etc. And that's why the Concorde was designed to cruise at about 2.3 Mach, because it's built out primarily aluminum. The airplane required special fuel, special engine oil, hydraulic fluid, everything. Even the solder for the electrical joints. When they were doing the early test flights of the A-12, several times they would come back with radio failure because the solder was melting out of the radios. So that was one of the problems that had to be solved. Okay, next.
What does it mean by preheating of camera cords?
That means they had to heat them up before takeoff so they would be at approximately the temperature that it would get to at cruise, so there wouldn't be any distortion in the images. Here's an illustration of the temperatures you get at normal cruise speed in the SR-71. To put that in perspective, if you have a self-cleaning oven at home, in a self-cleaning mode, it'll get up to about 550 or 600 degrees. Why was the airplane built out of titanium? Because titanium can withstand those high temperatures without losing strength, as aluminum does. You can see from this chart that it retains its strength almost as well as stainless steel, but titanium weighs about the same as aluminum. So the airplane is more than 90% titanium.
Was it a pretty expensive airplane to build? Yeah.
The airplane is a lot bigger than you might think. It's 107 feet long. And with full fuel tanks, it weighs about 140,000 pounds. This gives you an idea of where components are located. Blue is fuel tanks. So the empty weight of the airplane was about 60,000 pounds, and it carried 80,000 pounds of fuel. So more than half of the weight was fuel. Okay. Because of the stealth requirements, in addition to the exotic shape, it had composite material on the leading edges of the wings, the engine inlet spike body, and then what we call the chines here. And that helped to cut down on the radar reflectivity. Yes,
They used graphite for that?
a graphite composite, yeah. Okay, the navigation system, that was one of the major technical breakthroughs. Before the SR71 started development, the Air Force was trying to develop a air-launched ballistic missile called the Skybolt. It was designed to use on B-52s or British Vulcan bombers. It would be launched from the bomb bay or the wing of the bomber, go into a suborbital path, and hit its target several thousand miles away. It had a special navigation system developed just for the missile that was called an astro-inertial system because it used an inertial navigation system, which primarily relies on gyroscopes, but it also had a star tracker that automatically kept the inertial system updated for better accuracy. Well, the Skybolt missile program had been canceled, and they had these astro-inertial systems just sitting in a warehouse. So Lockheed found out about it and managed to grab those for the SR-71. The problem was, with a air-launched ballistic missile, it only has to go from one point to one other point. So it didn't require much memory in the computer system. It only had 8 kilobytes.
Guys, that's the hard drive memory of this board. 8 kilobytes. Kilobytes, 1,000, right? 8,000 bytes.
And you probably got a couple of gigabytes in your smartphone, right?
Okay, megabytes a million, gigabytes a billion.
Remember, this was the 1950s we're talking about,
So think about the concept here with these computers.
when the average computer was about the size of this room.
So this was way before ICBMs then? These were
Well,
like-
ICBM, well, no, ICBMs were in operation about the same time. Yeah. So one of the major technological breakthroughs in adapting this system for the SR-71, because it needed to go more than one point to one other point, it needed to be maneuverable and be able to change destination and route, etc., was a 64 kilobyte memory board. So think about it now. 64 kilobytes doesn't sound like much. But if you check into the history of the Apollo spacecraft program, you'll find that the navigation computer on the Apollo spacecraft only had 32 kilobytes. Did you ever see the movie Apollo 13? Remember when they had the problem and they're up there flipping switches? That's because they had to talk to the computer in machine language. That's all it could understand. Okay. The window for the telescope that looks at the stars is right here. The way it looked at stars in the daylight is it had a system of filters in it, so it only looked for certain wavelengths of light, and it managed to ignore all the bright sky background and everything. Okay. The engine was a big advancement too. To my knowledge, it's still the only engine ever designed to run in continuous afterburner.
So it consumed fuel pretty quickly then?
Yeah. However, once it got up to cruise speed at altitude, the fuel consumption was about the same as a Boeing 727. And the unique thing about the airplane design was it was designed to get maximum range at maximum speed. I'm pretty sure that's the only airplane that ever did that also. The difference was that if you had a malfunction and had to descend to lower altitude and go home subsonic, it severely restricted your range. The range at Mach 3.2 at 80,000 feet, for example, was about 55 nautical miles per 1,000 pounds of fuel. To go home at 0.9 Mach at 30,000, you're only getting about 30 nautical miles per 1,000 pounds. There were some missions that we flew that were so critical on range that if you couldn't go at max speed, you couldn't make it. I'll get into one of those in a little while. Okay, next. The original engine starter was pretty impressive. It was two Buick Wildcat V8s built by Mickey Thompson's Speed Shop in Southern California. About 400 horsepower each.
So just to start the jet engine, you need.
So, and it was connected to a common transmission with a vertical drive shaft that went up into the bottom of the engine nacelle to connect to a geared drive to start the engine. So to get the aircraft J-58 engine up to idle speed, you had to get the Buicks up to about 6,000 RPM. And they were straight exhaust with no mufflers, so it sounded like a drag race every time you started one. Later, they ran out of the Buick Wildcat V8 blocks and replaced them with 454 Chevys, same idea. But then by the time this next little video clip, this is the Buick unit right here. You see it's pretty big. And it took high octane gasoline for various engines, maintenance and the difficulty in obtaining the racing gas and so forth. It was later replaced with a air turbine unit, which was a lot more practical, but not nearly as much fun.
So you had two V8 engines just to start one engine to idle.
Right.
That's amazing.
Now, is that just special for this kind of jet engine, or did
Yeah.
Colonel People
Yeah.
start as F-15E?
No,
same
no,
way?
most airplanes have built-in starters.
Okay.
This one only had a geared arrangement with the power coming from outside to start the engine. The next slide is a video clip. Maybe it'll work. It shows you an actual engine start. To start the engine, you needed what we call a hypergolic fluid, because the fuel has such a high flash point that it cannot be started with normal igniter plugs. We had to use a fuel called triethylborane to squirt a shot of that in there to light off the JP7 jet fuel. And that green flash you see coming out of the engine is that triethylborane igniting, which then ignites the jet fuel. So we normally start it up in the hangar and taxi it out of the hangar. Okay, the engine in effect turned into a ramjet when you got up to max speed. This inlet spike here moved aft as you got faster. And unlike most Mach 2 class airplanes where they have a ramp or a spike or something that keeps the shock wave out of the engine inlet, the SR71 was designed to capture the shock wave inside the inlet for maximum pressure recovery to the compressor phase. But you always have to have subsonic airflow to the compressor phase. By capturing the shock wave in here, it gives you high pressure air to the compressor phase, and that gave you more power the faster you went.
So about what RPM would these engines spin at when you're?
Let's see what it was. Somewhere around 3,500, 4,000, somewhere in that range. Okay, the sensors, I mentioned we had several. We had an advanced synthetic aperture radar system. This was a radar that made images that were so detailed they look almost like photographs. At 100 miles range, if there was a submarine on the surface, you could identify the type of the submarine. Or you could look in an open hangar door and tell what kind of airplanes are sitting in the hangar
At 100 miles.
at 100 miles.
So that's like looking at Phoenix from here and
Yeah.
saying what kind of car's driving on the street.
Right.
Crazy.
The primary cameras were the technical objective camera. We had two of them, one on each side. 48-inch focal length, used 9-inch film. And the specs call for 6-inch resolution from 80,000 feet. On a good day, if everything was working just right, you could do slightly better than that. I've seen pictures taken on a training flight where you could actually pick out golf balls on a green on a golf course.
Wow.
The OBC, the optical bar camera, had a rotating lens, and it photographed basically from horizon to horizon. It could give you a good photo mapping of 100,000 square miles per hour. Of course, this was before digital cameras. The U-2, which is still flying, is converted to mostly digital now, although it is still using film cameras for certain missions. But this resulted in miles of film after every mission, so it was processing the film and analyzing it was a big job.
How long after landing could someone actually look at the film and get some results?
Probably less than an hour. We could fly a mission over North Vietnam, for example, come back to Kadena Air Base, Okinawa, develop the film and get it to Saigon, to MACV headquarters, in time for them to plan the next day's mission. Okay. This gives you an idea of what the various sensors can do. These orange areas are what the radar could look at. These small squares are what the technical objective camera would look at, and this blue swath here shows the path covered by the optical bar camera. I should mention that the optical bar camera and the radar could not be used at the same time. The airplane had interchangeable noses. One nose had the optical bar camera, the other one had a radar. You could change them between missions, the whole nose of the airplane. For the whole, yes.
How would you change the nose in mid-flight?
Oh, you don't, you have to do it before takeoff. It has
He
to be
gets
done on the
pops
ground.
the hood, he gets out real quick.
No, you have to do that on the ground. You have to decide before the mission whether you want radar or the optical bar camera. Yes.
When you guys flew missions over the USSR, where did you take off from and where would you land?
Well, let me make it clear to begin with. Gary Powers was the last guy to fly an authorized mission over the Soviet Union. We flew along the borders a lot, but we didn't actually overfly. Okay? For the whole operational history of the airplane, it was operated by the 9th Strategic Reconnaissance Wing of Strategic Air Command, based at Beale Air Force Base, California. We had two primary overseas detachments where we did most of our operational missions. That was Kadena Air Base, Okinawa, and Mildenhall RAF Base, England. Yes.
Did you guys ever land or take off at Edwards Air Force Base?
Oh, yeah. Okay, next one. Okay, how do you get to be an SR71 pilot or navigator? Well, the first thing you have to do is volunteer. And what we were looking for was under 35 years old, physically fit. That meant you had to pass the same physical exam that astronauts and test pilots do. And had a high-performance jet experience. If they liked the looks of your application, they would invite you to Beale for a series of interviews. You would get to fly in a T-38 to see if you could fly instruments in formation. You get a practice training flight in the SR71 simulator, see how you adapted to new type systems. And then if you got through all that, then they would send you for the physical exam. When I applied, you still had to go down to Brooks Air Force Base, Texas, to do that exam. That was where they had tested all the astronauts and the test pilots.
How did you even first hear about it to apply?
Well, that was strange too. It was so secret that even though at the time I was stationed at Hamilton Air Force Base flying the F-106, which is only about 150 miles from Beale, I had never heard of the SR-71. But Air Defense Command was still operating a prototype YF-12, which was the interceptor version of the SR-71. It never went into production. They built 3 prototypes and used them for test programs. But the Air Defense Command's YF-12 test pilot was a guy named Jack Layton. And Jack didn't get to fly the YF-12 all that much, so he would come up to Hamilton and get more flying time with us than the F-106. And I was the squadron weapons training officer at the time, and I was an instructor, so I would fly with Jack frequently in the F-106 two-seat trainer. And I was complaining one day about the YF-12 program being canceled and would never get a chance to fly something like that. And Jack says, well, if you'd like to fly something like that, you ought to check into the SR-71. I said, what's that? So he gave me a brief description, and it was a reconnaissance airplane operated by Strategic Air Command. So I started trying to apply, and I found out that the application procedure was in a classified supplement to SAC's personnel manual. And I was in a different command, so it was hard to get access to that. But I finally found somebody in Air Defense Command who had a friend in Strategic Air Command headquarters, and they finally got me just enough information to apply, which I did. Okay, here's what the pilot's cockpit looks like. You see, it's no fancy electronic displays. This is just a map projector. It uses a 35 millimeter film strip with a projector to project your flight path on there with a flight plan on it, which had to be built before every mission. All the rest of them just plain old round gauges, except this one right here, which is called a TDI for triple digital indicator, had equivalent airspeed, true Mach, and true altitude that were derived from the flight data computer, air data computer. The only other digital displays are right here, the EGT, exhaust gas temperature. So when you sit, after flying the F-106, getting into this cockpit was like taking a step backwards as far as instrument technology went. It was like getting into a Mach 3 T-33, for example. But anyway, that's one of the reasons for the long training requirement, because there's so many gauges, so many of them unique to this airplane that you'd never heard of before, and you had to learn what all of them meant, what was important, and what you had to watch all the time. This is the SR-71B pilot trainer. You notice it's got a raised cockpit for the instructor right here. Because of that, the stability was degraded a little bit, so they added these ventral fins over the engine nacelles. Yes.
Just a question about the picture. Do you know what those planes are on the ground?
They're KC-135s and T-38s.
Had special refuelers with the SR-71.
We had our own KC-135 fleet just for the SR-71, 2 squadrons total. I believe there were 35 KC-135Q models altogether.
We have about 15 minutes, so you might want to get to operational missions.
Okay, this real complicated getting ready for a mission. Start a day ahead of time normally, and start your suit up in your pressure suit an hour and a half ahead of time, for example. Why do we have to have a pressure suit? Because at the cruise altitude we're going to, if you lost cabin pressure, without the protection of a pressure suit, your blood would literally boil, which is not too healthy.
Anybody ever have to high altitude bailout?
Yes. This is what the pressure suits look like. During the time I was there, we went through various colors trying to come up with the optimum blend of wearability and lack of reflections in the cockpit and so forth. And one we're still using today is more or less like this one here. From our normal cruise altitude, you could actually see the curvature of the Earth. And you can see roughly 400 miles to the horizon from there. Okay, what was our mission? It was reconnaissance worldwide as directed by the President. In peacetime, we did planning for the big war, which we hoped would never come with the Soviet Union. And then our mission in war was to flying after the bombers and missiles hit and assess the damage. Typical mission profile looks something like this. We take off with a reduced fuel load, about half the capacity, level off at 25,000, 26,000 feet, go out and join up with a tanker and top off the tanks from there. The reason we did that was because it was too dangerous to take off with full fuel. The airplane had plenty of power, but you were pushing the tire limit speed if you did that. And if you took off with full fuel and lost an engine right after takeoff, there's about a 30 to 40 knot gap between liftoff speed and minimum single engine control speed. So if you lost an engine right there, your only option is to eject. First important mission was in Vietnam. Kadena Air Base right here is where we were based. We would take off, refuel in this area here, fly over North Vietnam, down into Thailand, hook up with a tanker, refuel and turn around, come back over North Vietnam, slightly different route, back to Kadena. That would take about 4 hours,
So you refuel how many times in 4 hours?
twice normally.
Twice.
Yeah. Once right after takeoff and another one in Thailand. This would be a U-turn type refueling track here, so you didn't have.
When SA-2s were shot at you, would you see them?
I never had one actually shot at me. I can't,
That you know of, yeah.
that I know of. But, yeah, we had an electronic warning in the cockpit if they were looking at us with a radar, and it changed the signal when they actually launched. One day we got indications that they actually launched, but we never saw missiles, so I don't know whether they did or not.
That's pretty cool. If he flies so fast, people will shoot at you, don't even know about it.
Then their next big mission, other than Vietnam, was during the Yom Kippur War in 1973, where we flew round trip from the U.S. to the Mideast and back to the U.S.
Okay, so you took off from America, flew all the way to the Middle East, and turned around and flew back.
Yeah,
How many hours?
10 to 11, 15,000 miles.
Guys, you don't get up and go to the bathroom during these flights, okay? You don't sit there and have a coffee, okay?
Well, I won't get into that unless there's some. Anyway,
But how many refueling? How much refueling?
5.
5, like where?
Well, we operated from 2 different bases for this mission, total of 9 missions. Started at Griffiths Air Force Base in New York.
New York.
Rome, New York. And the weather turned bad up there, so we moved down to Seymour Johnson, North Carolina, and flew the rest of the missions out of there. So we refuel once right after takeoff, just like once off the Azores, and through here, back to the Azores. One in the Mediterranean, back through the area, back, refuel again in the Mediterranean, and back to the Azores. But when we were refueling in this area, we were actually within range of Libyan MiGs. And there was a little bit of concern about that. So every time we refueled in the Mediterranean, we had F-14s from the carrier escorting us during the refueling. And I'm sure those Navy guys were just hoping those MiGs would come up and try something, but they never did.
So you have to come from your operational altitude, guys. It's up at 80,000 feet. You have to drop down to 30,
26, 27 normally.
which made him very vulnerable. He was ready to be shot down then after he gets his gas, have to go back up.
Back up again.
Question?
Yes.
Didn't the Libyans have MiG-25s that could chase down missiles?
I'm not sure that they had MiG-25s. They did have MiG-29s at that point, I think. But we didn't really worry about the MiG-25 because although their recon version could go Mach 3, they had to change the engines every time they did that. And they couldn't really cruise at Mach 3. But the fighter version with missiles on board could only do about 2.8 wide open, and we were cruising at 3.2. So we weren't really that worried about it. Okay, the plan for that Mideast mission had initially been to operate out of England. But because of concerns that the Arabs would cut off their oil, the British wouldn't let us come in, although it was pre-approved. So we had to operate a round trip from the U.S. We finally made it to England a year later, in 1974. we took the airplane to the Farnborough Air Show, and Jim Sullivan and Noel Whitfield set the New York-London speed record on the way over there, hour and 54 minutes. World record in about 5 hours, I think. And that included a refueling in the middle of the Atlantic. We could have made it in about an hour and a half, but SAC insisted they had to have enough fuel to order an alternate when we got to England. Then after the air show, we took it up to Milton Hall to see what the facilities looked like there, because we were planning on establishing a permanent operation there, and went back to the stage from there. Then after we got established at Milton Hall, England, which is just east of Cambridge, our main mission from there was to check out the Russian submarine facilities up here near Murmansk, the Kola Peninsula. And that was at the request of the Navy. They were really worried about the Soviet submarines. They had a new, what they call a Typhoon class submarine that had missiles range enabling them to sit in port and hit the U.S. So naturally the Navy wanted to keep track of all the submarines where they were at all the time.
What was the lowest altitude you took pictures?
Initial level off would be around 74,000, and we cruise flying from there.
And when you're above the PCA, above 550, flight level 500, were you talking to anybody?
Not normal.
Yeah, so I mean, you say goodbye and you fly all these countries and you come back, and then once
Yeah,
you
we'd
start
get-
dropping down.
We had, with our single sideband HF radio, we'd make mission reports.
Headquarters, yeah.
Yeah, but normally only 1 or 2 calls per flight.
Wow.
So next excursion out of the country to the air show was at Toronto, Canada, in 1977. And I took this picture because I thought it was so interesting seeing 2 airplanes by the same designer, only 25 years apart. You see quite a bit of development there.
Same designer.
Another one of our missions was the Siberian coast and the Sea of Okhotsk. This was technically international airspace, but the Russians considered it their private sea, so they didn't appreciate us flying in there. But we would do that every now and then. And to make the turns to stay over the water, we'd have to slow down to 2.8 Mach.
Because the turns are so large.
Yeah, at 3.2 Mach and 35 degrees of bank, which was your normal bank limit at 3.2, you'd have about a 75 to 80 mile turn radius. At 2.8 and 45 degrees of bank, you could do about a 35 mile an hour turn radius. Yes.
If you ever flew over the U.S. and you had to make a U-turn, how many states would you have to cover to make the single U-turn?
I'll show you a map that illustrates that in just a couple of minutes, okay? Then our next big mission was in the Persian Gulf. The U.S. had some pretty convincing intelligence that the Iranians up here had some silkworm anti-ship missiles threatening all the traffic in the Persian Gulf. But the satellites could never find them, because just like anybody else that has any technological base, it doesn't take too much to figure out when the satellites are going to come over. So all they got to do is hide them when the satellites are due overhead. So to find them, we sent an SR71 mission in there, which was a surprise. We confirmed 4 silkworm missile launch sites on the very first mission. So satellites have their disadvantages. This shows the major theaters we operated in. The Caribbean would be mainly Cuba. Central America was Nicaragua during the Sandinista period. Northern Europe, I've talked about. North Africa would be Libya, Egypt, etc. Middle East, Persian Gulf, and then all these areas in the Far East. Historical summary. The first flight of the airplane was December of '64. The first op sortie was March 21st of 1968. The airplane was retired by the Air Force in 1990, although it was brought back for a brief period in the mid-90s at the insistence of Congress. But then President Clinton canceled it for good with his line item veto in about 1995, I think it was. But NASA operated 3 of them on various test programs until October of '99. That was the last flight. Total of 31 built, 12 were lost, all in accidents. None was ever shot down. There were a total of 86 pilots and 86 RSOs who actually flew operational missions in the airplane. And this details all the accidental losses. He was the only guy ever killed. He was a Lockheed test engineer. This was because the airplane disintegrated around him at 3.18 Mach. It's a long story associated with that.
The pilot lived, though.
Yes. In fact, he was flying again 10 days later.
3.18.
18.
And he lived.
Yeah. Literally ripped out of the ejection seat by the forces of the breakup and ripped his seatbelt off.
That's a lucky guy.
Yeah, very lucky. Okay, next one. The significant thing about this is once we figured out all the ways you could lose an airplane, we went 17 years before we lost the next one. That was due to engine failure, which catastrophic engine failure with turbine blade severed lines from both hydraulic systems and lost control.
We have 10 minutes.
Okay. And these are the records. All of these are still held by the SR71.
Tell them about your closed course. You got that?
Yeah, well, interesting thing about this one, and this one, it was originally designed to be an around the world speed record. And it was approved by SAC headquarters. They were all for it. He got to the Chief of Staff of the Air Force and he looked at the detailed plan and he saw that it took roughly 100 tanker sorties to get the tankers in position, fly the mission, and get them back home. He says, come up with something else. It's too expensive.
They're going to go around the world, but he canceled it.
Yeah, so anyway, so we did 3 different records, all of them on local flights out of Beale Air Force Base, although the courses were down at Edwards and required no refueling support. Here's the one I flew right here. We took off from Beale, accelerated out over Nevada, came back across Edwards Air Force Base right here. Did this teardrop type course. Here's Prescott right here. Kingman, Needles. This is a 45-degree bank turn all the way around this course. We entered the course at about, I think it was 71,000 feet and minimum afterburner doing 3.3 Mach. Went all the way around the course. We started having problems with the exhaust nozzle controller on the right engine. It started fluctuating. So we backed off a little bit on the speed so it could cool down. It worked okay for a while. And started doing it again, backed off a little bit more on the speed. And the afterburner blew up just as we exited the course here. So it lasted just long enough. So we just started a descent from that point and landed back at Beale. And they changed the engine that night and did the 2 other flights the next day. That's why there's different dates on the 3 records.
So you're 2,000 miles an hour with the minimum afterburner, and it blew up.
Blew out.
Blew out.
The
Okay.
afterburner blew out. Yeah.
Wow.
So then off into the sunset at 1990.
Actually, is this one in the video?
Yeah. So this is what it looks like when you leave a tanker and accelerate and start climbing out again.
That's fun.
Okay, we got time for any questions?
All righty, yes, we have about 5 minutes, sir.
What was your highest speed you personally?
Highest speed I ever went was 3.37 Mach,
And how fast is that in miles per hour?
about 2,300.
How long does it take from when you refuel to get back up to 80,000?
Probably 10 minutes or so. We took off from Kadena one day on a test mission after an engine change. The only requirement was to take off, go out to Mach 3 at 80,000 feet and make sure everything worked, turn and come back and land. So my backseater and I timed it from brake release on the runway to 80,000 feet at Mach 3. It took 10 minutes and 45 seconds, which were about 200 miles away by then. But that was taking off with reduced fuel though, just enough to go out and do that and come back and land. Yes.
So, how many states would you have to cover to do a U-turn?
It depends on the size of the state, but the turn radius would be about normally 75 or 80 miles, so, 150 miles across the circle there. But
Do you remember the first day you flew in the SR71?
first day I flew,
Yeah.
while I was in training, not really.
The simulators were not as advanced as they are now.
No, there's no visual.
Simulators are very rudimentary relative to now. So when you got in a real plane, that's a real plane.
Yeah, we're flying a T-38 all that time, to stay current in flying, but first flight, usually just go out and do a refueling and maybe go out to Mach 3 and come back and practice some landings. The airplane was actually easy to land. Although you're coming at high speed, but compared to a U-2, for example, it was a piece of cake.
Cadet Burton.
What was your favorite thing about flying the SR71?
Probably the favorite thing about flying it was the visual sensations. When you get up that high and that fast, if you're heading west right after sunset, for example, you can watch the sun rise in the west at the same speed it normally comes up in the east.
Wow.
You're going 2,000 miles an hour, and the Earth is moving at roughly 1,000 miles an hour under the sun, so you're canceling that out and going the other direction.
Any major emergencies that scared you?
Well, I was an instructor in the SR71. We were in the two-seat trainer. I was checking out a new pilot one day, and we were doing a simulated single-engine approach at Beale. And the go-around procedure from that was to light the afterburner on the good engine. We did that, a big bright red firelight came on. So, and it was only on his second or third flight, I think. So I took control of the airplane from the back seat and pushed the other engine up, pulled that one back. We shut it down, but the firelight stayed on. We thought we were going to have to bail out. We managed to make it around and get it on the ground, but it burned a hole about that big in the engine nacelle. What had happened was the afterburner spray bar had a defective weld and it came loose when we were at the afterburner and just diverted the flame right into the side of the nacelle.
That can kill you.
Yes.
What's the highest you could eject out of while being safe? Could you eject at 80,000 feet?
Yeah, the pressure suit would protect you. The way it works, it didn't have a capsule like the B-58, for example, but the pressure suit would hold you into the ejection seat, or the harness would hold you in the seat. And there was a small drogue chute on the ejection seat that would stabilize it. You would free fall to 15,000 feet, and then they would kick you out of the ejection seat and your parachute would open automatically. Yes.
How long did it take to fall all that far? Or how long would it take?
Oh, I don't know. I'd just be a wild guess. I'd imagine 7 or 8 minutes at least, though.
Thank goodness he didn't have to figure that out.
Yeah, I never had to eject.
But people did live. I mean, he just
Yeah,
said
the
people
one that
did
we
live.
showed you, the airplane disintegrated at 3.18 Mach. It was on an early test flight, Lockheed test crew. And they were having trouble meeting the range specifications because the elevons were deflected up too much at speed. So they deliberately flew a test mission with the center of gravity after the normal limit, which would give you less trim drag. Anyway, they went into a turn, they have what we call an unstart, where the inlet malfunctions and expels the shock wave. The airplane immediately rolled into the turn and pitched up, even though he had full forward stick, couldn't control it. And the airplane just came apart around it. They were at 3.18 Mach at about think 80,000 feet or so.
All right, anyone, any last questions? All righty, I'd like to thank you so much for coming. I really appreciate it.